Hey, welcome back to your favorite Math 126 class. We're going to look at complex numbers in this section. I'm going to give you a little bit of background first. Uh, Carl Friedrich Gauss was, I believe, who invented or proposed solutions for equations of this form: x squared plus 1 equals 0. And up to this point, there's no real number solution for this. So when they square rooted, you would just say no solution at this point. Well, what Carl Friedrich Gauss did is he said, you know what, let's open up a whole new numbering system and let's call this square root of -1. Let's call that I. So this answer actually is plus or minus I, right? So that's what he did is he said I is going to be the square root of -1. So if I square that, it will undo it. So I squared is -1. So that's really what you want to remember. I is the square root of -1, so I squared is -1. And let me kind of show you a little, let's see if I can find some room here, graph of how these complex numbers fit in with the real number. So any complex number, that's a symbol for complex number, is anything of the form a plus bi. A and b are real numbers, okay? So you probably remember your real numbers. Let me remind you about your real numbers here. Your real numbers, so here's the symbol. Real numbers are made up of all rational numbers and irrational numbers. Okay, so your irrational numbers are like square root of 2, pi, or negative pi, or negative e, negative root 7. In decimal form, it's any number that does not terminate or repeat. Whereas a rational number is anything of the form a over b, where a and b are both integers. So like a half or -1/3, right? Those are all rational numbers, even just 2, right? 2 is 2 over 1. So the rational numbers, the integers are a subset of the rational numbers, right? The integers are ... -3, -2, -1, 0, 1, 2, ... The whole numbers are a subset of them. And the natural numbers, the counting numbers, 1, 2, 3, and so on, are a subset of those. So that's all your real numbers. And so a complex number can be written in the form a plus bi, where a and b are real numbers. Like if a is 2 and b is 3, 2 plus 3i. Now the complex numbers are made up of real. There's a real part. Here's the real part, and an imaginary part. So you have your pure imaginary numbers over here. Pure imaginary numbers, that's the bi part. Pure imaginary numbers, the bi part. In other words, a would be 0 here. So like 3i or -7i or even a pi I, as long as that b part is a real number, or negative e. E is also an irrational number. We'll talk more about e later in this course. But let's get back to solving these then. If you're trying to simplify I to the 38th, what you want to do is you want to use this information right here. You want to use the fact that I squared is -1. So you're going to write this as the power of a power in terms of I squared. So you say, well, 38 divided by 2 is 19. So see, power of a power, 2 times 19 is 38. So this is the same thing. And you know I squared is -1. So -1 to the 19th, -1 times -1 times -1, 19 times, right, would give you -1 because it's an odd amount of times. Let's do it for 359. So 359, if you take 359, you're like, well, let's see. Let me do that as 358 so I can split up the I and then another I. There's 359 total I's. And then let me split the I squared. 179 times 2 is 358, and I still have a leftover I to make 359. I did that because I know I squared is -1. So -1 to an odd power is -1, and I still have this leftover I, so -1i, which we don't have to write the 1 because we know the coefficient. We don't need to write that coefficient if it's 1. So it's just -i, -i. So I to the 233, I would write that as 232 and another I. There's 233 i's. The reason is so I can split that I squared up into 232 divided by 2 is 116. So I have 116 of these, I squareds. And we know I squared is -1. So -1 to an even power, right? -1 times -1. 116 times is just a +1. Well, 1I is just I. So that's I to the 233. And that's how you kind of approach those. Now let's name, a complex number is anything of the form a plus bi. A and b are real numbers. So for example, 4 minus 13i. A plus bi. So the real part's the 4. The real part is 4. The imaginary part is that -13, the bi part, right? That -13 right there. So the imaginary part is -13. What if it's written in just 18i? It's a pure imaginary. Well, what's the number in front of it? Well, 0. So here's the real part. There's the imaginary part, the 18. That's called a pure imaginary number. So any number, as I mentioned up here, any number can be written in this form, complex, in this a plus bi form. All real numbers are complex numbers. So even these numbers over here, like -2, -2 can be written in the form a plus bi. We just didn't ever write it this way. The bi part's 0, so it doesn't show, right? But it is a complex number. -2 is a complex number. So all real numbers are complex numbers. All complex numbers have a real part and an imaginary part. Now let's go ahead and simplify some now. So now that we can take square root of negative numbers. So what I do is I like to factor that. I know factors 144, 12, and 12, right? I'm looking for 2 of a kind. Square root of -1, there's my I. Square root of 144 is just 12. In other words, if I have 2 of a kind, it comes out. So this is 12i. So the real part is 0. 0 plus 12i is the same thing. 12 is the imaginary part, but we just write 12i, and we're done. How about square root of -15? So I'm going to write that as -1 times 15. And I can't do anything past that because I just got 3 and 5, so nothing. I can't take a clean square root out, so I just have the square root of I. I'm sorry, square root of -1, which is I. Remember, I is the square root of -1. I squared is -1, right? We're using this to simplify these radicals. And then I put these back. There's nothing I can do with those. So I root 15. Let's keep going. 80, -1, and factor 80 into, would that be 4 and 20? Or you know what? Let me do 4 and 4 and 5. All right. Square root of 16 is 4. There's my I comes out. There's square root of 16 is 4 comes out, and I'm just left with a leftover 5 underneath, right? So this is just 4i root 5. That's the square root of -80. Square root of -162. Keep going with these. So I have -1 times, let's see, 2 times 81. Square root of -1i. Square root of 81 is a 9. I'm left over with a 2 underneath, so 9i root 2 on that, right? Now this one's given in an a plus bi form, right? So go ahead and simplify the bi part and the a part, actually. Square root of 4 is 2 minus, now I'm thinking about this, square root of 16. So I comes out, square root of 16 is 4, so 2 minus 4i on that one. Let's keep going with these. 2's already taken care of. I got -1 times 90. Let me do that as 9 times 10. There's my I. Square root of 9 is 3, right? That's 3 and 3. And I'm just left over with a 10. So 2 minus 3i root 10 on that. Let's keep going here. 6 plus root -108. So I'm going to break up 108, let's see, that's 36 and 3. So 6 plus, I got -1, I got 36 and 3. It's all over 36. That's I. Square root of 36 is 6, and I'm just left with a 3 underneath. And then each of these can be over that. Oops. 6 over 36 is 1/6. Same thing here. So I got 1/6 plus 1i, or just I, root 3 all over 6. 1/6 plus I root 3 all over 6. All right, let's keep going with these. Do another one. Let me pause it, let you try that. All right, so hopefully you can see the process there on that one, on that you try. Well, the nice thing about these is now we can solve things of this form: 3x squared minus 4x plus 6, where our discriminant's less than 0. So we have ax squared plus bx plus c equals 0. So we're going to plug it into the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So we got 4 plus minus, I got 16. What's that? Minus 72 over 6. So we got, let's see, 16 minus 72, negative 56. And now at this point, we can actually do this now. This is -1 times 4. 4 and 14 is 56. Square root of -1's I. Square root of 4 is 2. So I got 2i root 14 all over 6. So each of these will, so I got 4/6 plus 2i root 14 over 6. So I got 2/3 plus I root 14 over 3, or, oops, plus minus on that. You could also say 2 plus minus I root 14 all over 3. Either of those, of course, is proper. And I'm going to go ahead and have you try this one now. Let me pause it. All right, have you check that one, and that is the end of our discussion on complex numbers, CR15. Appreciate you watching and taking notes. See you guys next time.